Hello. 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 Good morning to everyone. At the outset, I'd like to thank the organizer for giving me an opportunity to present this invited talk at 5th Interdisciplinary Research for Sustainable Development Conference being held in Chandigarh. The topic of my talk is green chemistry and its application in corrosion protection. These are the outlines. I will talk about the definition of corrosion, importance of corrosion studies, basic facts about corrosion, corrosion control using green concept of chemistry, then application of corrosion inhibitors in industry. So what is corrosion? Corrosion is defined as a deterioration of a material by its environment. Why metal corrodes? Metals are usually obtained by of ores. This process is called metallurgy. And when metal is obtained, they are in higher energy states. So they try to go back to their original states, and this process is called corrosion. As regard the significance of corrosion, every country loses 3 to 4% of its GDP on account of corrosion. Annual loss global is about $2.5 trillion. And in India, the corrosion losses are about $100 billion per year. So very huge amount is lost because of the corrosion. Therefore, a lot of efforts are required to protect metals from corrosion. These are the examples of corrosion: rusting of iron, you can see here, and corroded glass plate. And when corrosion occurs, the appearance of the structure becomes very ugly. You can see here this corroded ship and fresh ship. Corrosion causes destruction of metallic structure such as bridges, buildings, machine. You can see here total collapse of buildings and collapse of this Mandvi bridge. Sometimes fatal accidents also take place. For instance, release due to release of the toxic gases in the atmosphere. For instance, methyl cyanide gas released from the carbide plant Bhopal. Similarly, in Chernobyl nuclear disaster is also known to everyone. Due to release of radioactive material, several people died. What are the importance of corrosion studies? We can avoid the wastage of material by the education of corrosion, and we can also avoid the losses occurring due to corrosion. Corrosion is omnipresent. Corrosion takes place in air. It can take place in water as well as soil. And you can also see the corrosion may also take place in human body. And this I have shown the steel structures in the human body, and that also undergo corrosion in presence of body fluid. These are the basic requirements of corrosion. Corrosion will take place due to the existence of micro corrosion cells, which essentially consist of anode, cathode, electrolyte. There are various types of corrosion. Dry corrosion takes place when metal comes in contact with dry gases like oxygen, H2S. Wet corrosion occurs in presence of moisture. Example is rusting of iron. Hot corrosion takes place by the interaction of metal in molten salt. Biocorrosion means interaction of metal with microorganisms and bacteria. The two types of corrosion cells are involved in corrosion. Galvanic cell. In galvanic cell, two dissimilar metals are in contact, and active metal act as a anode, and the less active metal act as a cathode. Similarly, concentration cell, the metal is same, but the concentration of the corrosive species is not uniform around the metal. For example, when the concentration of air or oxygen is not uniform on the metallic surface, then this kind of corrosion will take place. And these are the examples of concentration cell. You can see this cracked metallic piece. In the crack, oxygen is less, so this area will act as an anode, and while the surface of the remaining metal will act as a cathode. So the corrosion will take place here. Similarly, riveted joint also, because of the difference in concentration in this structure, corrosion will take place. Corrosion is an electrochemical process. It involves two processes. One is oxidation. So here I have taken the example of oxidation take place as anode. Iron is oxidized. It releases electrons. And now these electrons go to cathode and they will reduce oxygen into hydroxide ion in neutral medium and proton in acidic medium, and hydrogen evolution will take place. So this is the mechanism of weight corrosion which take place in presence of moisture. Example is rust formation. So this iron is oxidized at anode and ferrous ion form. At cathode, oxygen is reduced and hydroxide ion are formed. Now these ferrous and hydroxide ion, they react together and they form the rust. Rust formation is causes severe consequences. The volume of rust is 20 times more than iron. So when the reinforced steel gets rusted in concrete environment, this spalling takes place, which causes collapse of complete building structure. So we should always avoid the formation of rust in metallic structures. This dry corrosion takes place in presence of dry gases like oxygen and other gases. So here metal is oxidized to metal ion and reduction of oxygen take place at cathode. Oxide ion is formed, and finally this metal ion and oxide ion, they form the oxide layer on the metal surface. We can easily find out the existence of anode and cathodic areas on the metal surface using ferroxyl indicator. When a drop of electrolyte is placed on the metal, iron is formed. It will react with ferricyanide and blue color will appear in the center, and at the periphery oxygen reduction will take place. So hydroxide ions form, and this hydroxide ion will react with the phenolphthalein and pink color will appear. So when this drop of electrolyte or water is added on the metal, you can see blue color as well as red color. That shows the presence of anodic and cathodic area on the metal surface. And we can also measure the corrosion rate. Very simple method is gravimetric method. What we do, we immerse a steel specimen in the corrosive solution. For instance, it may be acid or it may be water for a definite period of time, and the corrosion rate can be calculated by this simple formula, where W is the weight loss in presence of corrosive environment. Area is the area, this A is the area of the specimen, T is the immersion time, and D is the density of the metal. This corrosion occurs, various forms of corrosion are there, and there are 8 forms have been known. Uniform corrosion takes place all over the metal surface. Galvanic corrosion will take place when two dissimilar metals are in contact. One metal is active, another metal is less active. So active metal will act as a anode and less active will act as a cathode. So due to due to presence of two dissimilar metal, galvanic corrosion will take place. For instance, when a steel pipe is connected to copper plumbing, steel shaft, second example, steel propeller and connected with the bronze. So these two metals are in contact, the corrosion will take place. You see this is the national symbol, Statue of Liberty in USA. This is made by two metal. One is outside is copper and inside is iron. So after installation, after a few months, this structure collapsed because of the corrosion in the iron. So engineers were called to see why this has collapsed. Then it was found out because of the galvanic corrosion. This was corrosion has taken place. So engineers, what the engineers do, they place a insulating material between the copper and iron. So the corrosion was uh, reduced. So for preventing corrosion, the simple method is by placing a insulating material between the two metal. And this is the galvanic series in seawater, and you can see the bottom of this active metals are there, aluminum, zinc, and magnesium, while the top this less active copper, bronze are there. Crevice corrosion takes place in shielded areas where the concentration of air or oxygen is not uniform. For instance, in rivet joint, you will find this kind of corrosion. Pitting corrosion appears in the form of pits, and mostly perforation take place. And this kind of corrosion mostly occurs in steel in presence of chloride ions. So this is the mechanism how the pitting corrosion take place. Intergranular corrosion is mostly occurs in austenitic steel during welding conditions. What happens at the grain boundaries? This chromium is deposited and chromium concentration is formed. So because of the formation of this galvanic cell, this kind of corrosion take place. However, we can reduce or minimize this corrosion by adding titanium in the alloy stainless steel. Selective leaching means one of the element from the alloy is removed. For example, dezinkification. So dezinkification, what happens? The zinc is removed from the brass, so this brass material becomes unfit for the use. So another is erosion corrosion. This is caused by mechanical action of flowing liquid on the metal surface, and phytic corrosion because of the mechanical action of solid body on the metal under load and moving condition. So these are the examples I have shown here. Stress corrosion takes place when the tensile stress and corrosive environments they work together on the material, and this kind of corrosion appears in the forms of crack. One of the bridge in USA collapsed because of the this stress corrosion cracking. Silver Bridge because of this stress corrosion in Ohio. So we should avoid all these kinds of corrosion. We should take proper measures for avoiding these kind of corrosion. Hydrogen damage, this kind of corrosion occurs in contact with acidic environment. So what happens in acid environment? The hydrogen will go into the metal, and then after some time accumulation, lot of hydrogen is accumulated inside the metal, and when this hydrogen bubble bursts, then a blistering type of corrosion takes place. So this is also a severe kind of corrosion, and mostly encountered in petroleum industry where acidic environment is found. Now there are various factors for corrosion. One of the important factors is relative humidity. So corrosion will only take place when the relative humidity is more than 55, and below this no corrosion will take place. So if we want to protect the metal from corrosion, then we have to maintain the relative humidity less than 45, and this kind of work can be done by using dehumidifier. You see here, this is the iron pillar of Delhi, and this is known as rustless beauty of the India, and it was built by the King Chandragupta in 1915. So it's very old, but still we don't find a significant corrosion in this structure. So the reason for This why it is not corrosing is due to the formation of ferric phosphate film on the metal surface, because when this was built, some phosphorus was added to the iron, and so ferric phosphate was formed, and that is responsible for why it is not corroding. Another factor that causes corrosion, that in a polluted environment, the corrosion of metal is high as compared to clean air. This is very important map, corrosion of map India. Uh, this shows the corrosivity in different region of the country. You see the corrosion rate is high at this coastal areas and blue and pink area, and this area, that's what we call yellow area, the corrosion rate is less. So the importance of this corrosion map, then this help us in selecting the material of construction. When we have to use material at coastal areas, then we have to use good material whose corrosion resistance is high. And suppose you want to use some other area where corrosion rate is less, then we can use ordinary material for construction. And this is the Pourbaix diagram, means shows the effect of pH on potential. And you see that the iron is corroding at all the pH except a very small region here, 10 to 12, another region it is undergoing corrosion. But this can be protected by applying suitable method. For instance, if you apply a potential on anodic side, and the material or iron can be passivated, and if you apply the negative potential on the metal, then the metal will go into immunity region and this will not corrode. So electrochemical method plays a very important role in protection of metallic corrosion. These are the important methods of corrosion control, electrochemical methods of corrosion control: coating, designing, and corrosion resistance alloys, and by use of corrosion inhibitors. Corrosion inhibitor is also very important method, and by using these methods we can 30 to 40% losses can be saved. Corrosion control by different methods includes design, coating, inhibitors. Design is very simple. For instance, suppose we want to join two metals. So one method is you can use bolt joint. Yeah, this figure one is bolt joint is there. And you can also join these two metals by weld joint. So here weld joint is considered as best design as compared to bolt joint, because in bolt joint oxygen may enter into this crevice. So corrosion will take place, but no possibility of entering or formation of oxygen concentration in weld joint. So this is better. Similarly, sharp corner are dangerous for corrosion, because here the dust or some material can be deposited here. So when you construct this kind of design, then the corners should be smooth. So smooth corners are always desirable in design. We can also control corrosion by coatings like galvanizing. Galvanizing means the coating of a zinc on the iron sulfate, and you can also protect the iron by tinning. Means tinning is uh, by applying a tin coating on the iron surface. So these are the important methods for corrosion protection. We can also minimize corrosion by choosing suitable material. For instance, suppose you want to use some material in nitric acid, then we cannot use any material. There are some corrosion resistance, and specific types of material can only be used in a specific environment. So nitric acids, in nitric acid, stainless is used, and this is the list of the metal which can be used in different corrosive environment. And tantalum has got the ultimate resistance. Microbial corrosion is also there. It is caused by the activity of the microorganism or bacteria. So bacteria also cause corrosion of metallic material, and these are the bacteria which cause corrosion. And this bacterial, they produce acidic substance in contact with metal that causes corrosion. Microbiologically induced corrosion can be caused by several kinds of bacteria, and this is the nitrifying bacteria, denitrifying bacteria, cellulose bacteria, and this fungi. So these are the things which are causing the corrosion of material. Biocorrosion means which takes place due to presence of microorganism, and biofouling is the accumulation of living organism on the metal surface. So both the things they cause corrosion of schiffer, and this is the mechanism of microbial corrosion. And we can prevent microbial corrosion by using coating, by using inhibitors, or by using cathodic protection. Corrosion control by using inhibitor is also one of the most important method, economical also, and easy to apply also. So what are these inhibitors? So according to this NACE organization, inhibitor is a chemical substance which retards the corrosion when added in a corrosive environment at appropriate concentration. So this appropriate concentration is very important for retarding corrosion. And the another important thing, the concentration of the corrosive species should not change in presence of the inhibitors. So if the chemical satisfies these two conditions, so they will be called the corrosion inhibitors. The important qualities of corrosion inhibitor is it should be effective in preventing corrosion at low concentration. It should be thermally stable, chemically stable. It should be cost effective, and it should be eco-friendly also. A lot of these inhibitors are used in different industries. According to this market, around $6.9 million it was consumed this 2016. Now it is likely to increase by 10 billion in 2024. So market is increasing at the rate of 5%. And the more important thing is the oil industry and power industry consumes a lot of inhibitors. About 50% inhibitors are used in these two sectors. These inhibitors find wide application in petroleum industry, steel industry, sugar industry. This construction industry means corrosion protection of reinforced steel bars. Artifact means the corrosion protection of artifact from atmospheric corrosion. Food industry, corrosion protection of tin containers. So these are all application in various industries. So this is the mechanism of corrosion. As I mentioned earlier, two important reactions are involved: oxidation and reduction. Oxidation, metal ions are formed, electrons are released, and cathodic reaction take place depending upon the environmental condition. For instance, in acidic medium, hydrogen evolution will take place. In neutral medium, hydroxide ions will be formed. According to the electrochemical nature, we can have three kinds of corrosion inhibitors. First is the anodic inhibitor, cathodic inhibitor, and mixed type of inhibitor. So what are these inhibitors? Anodic inhibitor usually retard the rate of anodic reaction, that is the metal formation, and cathodic reaction retard the cathodic reaction. And these are the examples of the this phosphate, molybdate, and the cathodic inhibitors, the salts of calcium, magnesium, and this mixed kind of inhibitor means it is capable of inhibiting both anodic and cathodic reaction. So mixed inhibitors are considered as best inhibitor as compared to either anodic or cathodic inhibitors. And this category, heterocyclic compound play very important role as a mixed type of inhibitor. Heterocyclic inhibitors means they are a cyclic compound and at least one heteroatom is present in the ring. So here I have made this structure, 2-aminopyridine. So in this cyclic structure, one nitrogen is present as a heteroatom. So these kind of inhibitors are very good. They are adsorbed on the metal surface and on the both anodic and cathodic side, and they prevent corrosion. And this is also important. A suitable amount of inhibitor is used for corrosion protection. Otherwise, more corrosion will take place than the without inhibitor. So optimum concentration is required for corrosion protection. These are the practical application. Acid inhibitors, they are mostly used in oil gas industry and pickling of steel, and some inhibitors they are used in cooling water systems like benzotriazole. And this another kind of inhibitors, volatile corrosion inhibitors. These kinds are also very important inhibitors, and they are used during transportation and storage of metallic instruments. Now, next thing is what is green inhibitor. So according to Paris Commission, green inhibitor must meet following criteria. Toxicity, that is measured in terms of LD50, should be more than 300 milligrams. Biodegradability more than 60% in 28 days, and bioaccumulation should be less than 3. These are the organic compounds containing heteroatom, and they are considered as good corrosion emitters because of two important things. Is one is lone pair of electron present on heteroatom and pi electron present on in these rings. Through these characteristics, through these features, they are adsorbed on the metal surface. And these are the modified heterocyclic compound. We can modify the virgin heterocyclic compound by introducing more functional group. And if you introduce more functional group, their performance is further enhanced. And these are all modified corrosion inhibitors. There are certain guidelines for improving the performance of inhibitor by incorporating heteroatoms and electron donor group in the parent molecule. We can increase the performance. We can also increase the performance by increasing the size of the ring, by increasing the carbon chain length, by increasing the molecular weight, by enhancing the solubility, by introducing OH-NH2 group, by introducing double bond in conjugation. So if we are able to modify this structure by these guidelines, we can make a very good kind of inhibitors. And we have done a lot of experiment to verify these things. So we have introduced one electron donating group, so methoxy. So you can see that it has given highest efficiency 97, while the electron withdrawing group very 93%, and H and without any substituent is 94. So if you introduce electron donor group, efficiency will increase, and if you introduce a electron withdrawing group, the performance of inhibitor will be reduced. Similarly, if you increase the conjugation in the structure, the performance will be very high. Similarly, if you increase the size of the ring, then also you can have a good corrosion inhibition. And if you increase the carbon chain length in a structure of an inhibitor, then also you can have a good performance. So here you can see this glucose molecules with 6 carbon atom has given highest performance as compared to 2 carbon atom. High molecular weight compounds are more effective than less molecular weight. This is also very important thing, that is what is synergism, and this kind of synergism is used for increasing the performance of inhibitor. This is the example I have shown here, that this benzothiool molecules and in presence of potassium iodide as a synergistic agent. So you see that 100 ppm the efficiency 84, and 500 ppm without synergistic agent 98%. But if we take only 100 ppm little amount of potassium iodide as a synergistic agent, the same 97% efficiency can be obtained. So a small amount of synergistic agent is added, then the cost of the inhibitor formation is considerably reduced. And this is the mechanism how inhibitors are adsorbed. Adsorption, formation of diffusion barrier, blocking the active site complex formation. And this is the most common mechanism of inhibition, that is the adsorption. So adsorption on the metal surface can take place through lone pair of electrons or pi electrons like this. And various methods, simple methods can be used for evaluating corrosion inhibitors. The simplest method is weight loss method. What we do, we take a metal specimen and dip in corrosive solution for a fixed period, and naturally what will happen, the metal uh, weight will be reduced. So we will measure the weight of metal in absence and presence of inhibitor, and then we can find out the efficiency of inhibitor. A very simple example, suppose the loss of uh, metal in acid solution is 100 milligram and presence of inhibitor is 10 milligram. So by simple method we can say that it is 90% efficiency. We can also find out the efficiency by electrochemical method, linear polarization method, and potentiodynamic method. Linear polarization, we measure the resistance, polarization resistance at the metal in absence and presence of inhibitor. Then we find out the efficiency. Similarly, the other method, that is the potentiodynamic method, we measure the change in electron, what you call the current. Corrosion current is measured in absence and presence of inhibitor, and from the difference of this corrosion current we can find out the effectiveness of the inhibitor. And we can also see this surface by different characterizing tools, and we can see whether the corrosion is taking place. When corrosion occurs, then the surface becomes very rough, and in presence of inhibitor, the roughness is considerably reduced. This we can know through scanning electron microscopy. There is another method, that is the atomic force microscope, and we can find the extent of roughness from this method. For instance, this in absence of inhibitor is around 580 nanometer roughness, but when we add inhibitor, then the roughness is considerably reduced. Here example is one. So here about 580 to 190 roughness has reduced. Similarly, X-ray photoelectron spectroscopy, we can find out the nature of element adsorbed on the metal surface. This theoretical method, quantum chemical methods are also used for evaluating corrosion inhibitors, but I will not take this is I think not appropriate at this conference. These are very important thing. Green chemistry, application of green chemistry, we can protect corrosion. So what is green chemistry? Green chemistry deals with synthesis and designing of chemical products in environmentally benign method without using any toxic solvents. And these are the guidelines. We can synthesize corrosion inhibitors by using environmentally benign chemicals, means non-toxic chemicals. And what is the non-toxicity criteria? LD50 should be more than 300 milligram. By using microwave and ultrasound technique, we can save a lot of energy, and we can synthesize the compound in a very short time. We can use renewable raw material rather this what you call fossils material, this petroleum materials. So here the very important renewable raw materials, plant extract. We can also use safer solvent like water and PEG, polyethylene glycol, for carrying out the reaction, because they are non-toxic, non-volatile solvent. We can also use catalyst for um, for the chemical reaction, because this accelerates the rate of chemical reaction to a great extent. And you see, earlier also I told what are green inhibitors, that LD50 more than 300 milligram. They are considered as environmentally benign or green inhibitors, and less than 300 they come under the toxic chemical. So we should also see that whatever chemical we are using should be non-toxic. And this toxicity data we can find out from the Google, and we can carry out synthesize inhibitors, this non-toxic chemical, And we can also synthesize inhibitor by catalyst. These are the examples. And drugs are also considered as a non-toxic inhibitors. So we can use them as inhibitor, but they are very costly. So we have used expired drugs as corrosion inhibitor. And this work was highlighted in material discovery because they are very good inhibitor, and moreover, they are non-toxic. Expired drugs, another drug we have used, and this is astrovestage drug as corrosion inhibitors. We can also use microwave technique for synthesis of corrosion inhibitor. The example is we have synthesized this chitosan CIPS base. So conventional method takes place 3 hours for synthesis, while the microwave only 15 to 20 minutes are required. Similarly, we can also make use of the ultrasound method for synthesis of inhibitors because this takes less time. Multi-component reaction means many components in a single flask can be processed by microwave, chemical, or ultrasound method. The importance of this method that the number of steps are reduced as compared to multi-step reaction. And this biogenial reaction is a very important this reaction, and we can prepare these types of pyrimidine types of heterocyclic corrosion inhibitors. And this is the mechanism how these compounds are synthesized. And various compounds we have synthesized and tested as corrosion inhibitors. We have also obtained a good corrosion inhibitor from the shell wall of the shrimp. And this shell wall contains what we call chitin. And if you treat it with sodium hydroxide, it will be converted into the chitosan, and chitosan act as a very good corrosion inhibitor. So this work was also highlighted in and published in highlighted in Hindu newspaper. And we can also further improve the efficiency of chitosan molecules by chemical modification. Simple chemical modification can be done, and we can improve the efficiency of inhibitor. We can also use glucose derivatives as corrosion inhibitors. Glucose itself is a 69% efficiency at 500, but if we modify it, then we can reach the efficiency 96% at 500 ppm. Corrosion inhibitors also finds wide applications, and some of the applications are we have listed in petroleum industry. For petroleum industry, the commercial inhibitors are very toxic, so we have prepared non-toxic inhibitors. So this is the inhibitor for petroleum industries, and mainly used for acidization of oil well. And this inhibitor which we have synthesized is corrosion rate is very less, and while the commercial inhibitor corrosion rate is very high. And same thing is it is non-toxic also, and we have granted a US patent for developing this kind of inhibitor for petroleum industry. Antipyrine derivatives also used as corrosion inhibitors by our group. There are many inhibitors, so this pyrimidine types of inhibitors. Corrosion inhibitors we have also used for paper pulp industry, what you call lauric hydrazide. So lauric hydrazide in paper pulp environment found to be very good. For food industry also we have developed inhibitors for corrosion protection of tin container in contact with this orange juice, pineapple and mango. So we use glycine as a corrosion inhibitors and found more than 90% efficiency by this inhibitor. Plant extract can also be used as corrosion inhibitors. We have used peas, potatoes and orange peels for protection of metallic corrosion. We have also used barks of various plants as corrosion inhibitors for iron and aluminum. We have also used leaves of plant as corrosion inhibitors, and this outer skin of this watermelon can also be used as very good corrosion inhibitors. Volatile type of corrosion emitters also we have synthesized, and they were found to be very good as compared to commercial emitters. And these are used for corrosion protection of military weapons, electronic equipment, and precision component. These are the examples. And corrosion inhibitors for pickling and acidization, we have already given examples. For sugar industry also we have developed a chalcone types of inhibitors. They have given good performance. And for steel industry also we developed good inhibitors and compared their performance with commercial inhibitors. They were found to be more effective as compared to commercial inhibitors. And we have also developed inhibitor for reinforced steel bars. And in this case we have developed calcium stearate. Now this calcium stearate at 5% concentration give very good efficiency of 93%. So you can see this steel bar, and this without inhibitors some rust is there, and with inhibitor no rust is there. We have also granted in one patent on our inhibitors. So corrosion is a pernicious process that impairs the quality of environment and the efficiency of infrastructure. In present of energy crisis and economic turmoil, green chemistry play a vital role in corrosion protection of metal. Use of green inhibitor is one of the best option for corrosion control and extending the life of the inhibitors. This is the book which you can follow, basics for understanding the basic of corrosion, that is Mars Fontana. And this is the book written by us, Organic Corrosion Inhibitors, and published from Elsevier. And acknowledgement, I acknowledge the supports from our center director and various scientists. I also thank all my 50 students who have worked with me for PhD and M10 degree. And from Kurukshetra University, I did my PhD in 1986 under the supervision of Professor S.N. Dhawan. This is our research center in KFPM University. And I work at three important universities: Aligarh University as associate professor, IIT BHU as professor, and King Fahd I am working as a chair professor. Thank you very much.